All right, guys, welcome. We are going to be looking at the stats project, part one. And the last video I made needed to be redone. So that's why I'm going over this again. Now, remember that we're looking at the Excel document from the class, and I'm only doing this example for 7 students, but you have to do it for all the students in your class. So it is more work, but it is worth double points. So it's helpful to make sure that you get on that. Okay. Now, the first step that we have to do for step number 1, we have to make a dot plot. Okay. This is way back in the beginning of this unit. The dot plot is a matter of showing how many students had a particular response. Okay. This is different than what I had shown in the last video. I made a little mistake. So here's the thing. Our height is here. These are going to be our different heights in inches. These are going to be our number of responses. Okay. So this is going to allow us to see how many students are 62 inches versus 68 inches versus 66 inches. So I need to make a little warp right here because when I am, labeling this, or I'm going to be able to just number straight numbers for the y-axis, because I'm going to be counting how many students are of certain heights. For the height, I look here, and my lowest is 62, my greatest is 69. That's my range. So I'm going to go ahead and just start this at 60, 61, 62, 63, 64, 65, 66, 67, 68, 69. Okay. Now, when I go in here to do my dot plot, all I have to do is look up here and say, okay, 66 inches, 1 dot for 66 inches. All right, 65, 1 dot for 65. 62, 1 dot for 62. 64, 1 dot. 68, 1 dot. 69, 1 dot. Another 66, so then I put a second dot on 66. A dot plot is very simple to be able to see how many are in each position. Now, if you were doing a histogram, you would just make these into columns. You'd make them into rectangles. And that is just a quick reminder of what a histogram is. Mainly we're looking at dot plots. All right, next we had to, for number 1, we had to find the mean. We had to find the mean and we had to find the median. Okay, so if I'm finding the mean, I need to take all my numbers, all right, 66 plus 65 plus 62 plus 64 plus 68 plus 69 plus 66, and I need to divide it by the number of entries. There's 7 kids. So when I do so, I end up with a mean of 65.7. Okay, so we have our dot plot. Good. We have our mean. Now to find the median, I take all the values, and I put them in order, and I find the middle number. 62, then what's next? 64, 64, 65. There looks like there's 2 66s. There is a 68, there's 69. I could have looked here actually. Now that I look, I could have just said 62, there's 1, 64, there's 1. I was looking up here, and that wasn't the data here is easier to read. 2 66s, got it. All right, look, there's 7 numbers, so I need to go in 3. And our median is in the middle. This is our median. Median equals 66. That's also our Q2 for what's coming next. Okay, so we have dot plot. Easy. Median, the mean. Add them up, divide by the number of entries. Median. Put them in order, find the one in the middle. Okay, so next we have to make a box plot. That's number 2. It's gonna be a nice quick explanation for you. And I'm looking at this box plot. I already know my Q2 is 66 because that's the median, excuse me. Now to find Q1 and Q3, you have to remember that we look to, for Q1, we're looking at the bottom, right? The lower numbers from our median, not including the median. The lower numbers is 1, 2, 3. So guess what Q1 is? Q1 is 64. 64. All right, then I go from the upper half, and there's 3 numbers there, so the median of the upper half, our Q3 is 68. Okay, so look, I'm going to go ahead and put those numbers in there. We got 64, we got 68. Okay, now I know that my minimum is just the smallest number, 62. My maximum is just the greatest number, 69. The IQR is the difference between Q1 and Q3. It's what is the width of that box. The IQR is the interquartile range. 68 minus 64. That's all you have to do. Just subtract them, and we get an IQR 4. All right. Now in the assignment, that's everything for number 2. We got our box plot done. Okay. But in the assignment, I had actually put find the outlier. I put find the outlier as number 4, but actually I'm going to find the outlier right now. So I'm going to do the MAD, which is number 3 last. But here, and different periods, I changed this around. But now I'm just looking for outliers. Are there outliers? Question mark. If so, what's the measure of center? So this quickly is going through a lot of the topics. The outliers, it's going to be the IQR. This is how it always is. Times 1.5. And that is going to give you where your fences are. Remember the fences? The fences are some distance from the median. And if the numbers are beyond the fences, then we know that it's outlier territory. So let's put in what we have. The IQR for this problem is 4 times 1.5 is 6. So we need to do this. We need to go in, and from Q3, we need to go this direction plus 6. When I go this direction plus 6, I get all the way over here to 74. So anything 74 and greater would be an outlier. Do we have an outlier on that side? No, it's only 69. Next, since the fences are at 6, I go from Q1, and I'm going to go this direction minus 6, because to the left is minus. 64 minus 6 gets us over here to 58. Anything 58 and lower would be an outlier. Let's see where we got. It's 62 is my minimum. So there are no outliers. No outliers. So you find the fence distance. You go from Q1 and Q3 out that same fence distance, plus 6, minus 6. That's where your boundary for the fence is. This boundary for the fence is 74 and above. This boundary for the fence is 58 and below. Okay. So there's no outliers, and what that means, the best measure of center is the mean. If there's no outliers, we can use the mean. Okay. If there is an outlier, we use the median. So no outliers, you use the mean as the measure of center. Okay. Now the reason why I'm doing this last, this was the MAD, finding the MAD, is because I already have this set up like this here. And what I'm going to do is I'm just going to add to this, because now I'm doing the MAD. Okay. I'm going to add to it. This is going to be our absolute deviation. Okay. So look what we're doing right now. We have our data points. What we have to do is we're comparing each data point to the mean of all the data. So I look here and I have to find the mean first. I already did this. The mean was 65.7. Okay. So the first step when you're finding the MAD is to find the mean of the data points. Then in this column, we're going to go 65.7 minus 66. 65.7 minus 65. Okay. 65.7 minus 62. These are all absolute valued. 65.7 minus 64. 65.7 minus 68. 65.7 minus 69. And 65.7 minus 66. It doesn't matter that they're not in order, because we're just finding these values, then we find the average of these values, and that's going to give us our final value. All right, let me see if I do this. Yeah, I already wrote these down, so I'm just gonna copy them down here. This gives you 0.3. 0.7, 3.7, 1.7, 2.3, 3.3, 0.3. Okay, so these are all, this is important, we're almost done. These are all of the absolute deviations. What it is saying is we found the average, and each point is calculated. We're finding out how far each of the points are from the mean. And look how we find that. The mean minus the point absolute value gives you the distance between 66 and 65.7. We did that for all of them. So now the MAD is just taking all these. The MAD is just taking all these and we're finding the average of all these. So this would be like 0.3 plus 0.7 plus 3.7, right? Dot, 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 divided by 7. And I already worked this out in another bit, so I'm just going to put it here, 1.76. Okay. All I did there was find the average, right? This is just the average of all of these. The average of all those. And that concludes, that's a 10-minute video, 12-minute. That's great. All right, guys, I hope that helps you get started, and we'll have part 2 coming up.